This video is for lesson 4.5, which is disjunctions of inequalities, and it builds off of the one we had right before this, which is conjunctions. So if you remember from conjunctions, that is where you're doing and, where you're taking two different inequalities and taking their answers or their solutions, and you are saying, so one thing needs to happen and the other needs to happen. So you're looking for where the two, what they have in common or where they overlap. So disjunctions, instead of having and, we're using or. So the symbol that we use is this little symbol that looks kind of like a V. That is your disjunction symbol, and that means or. And we'll explain a little bit as we go about how that's different from the conjunction, which is and. So just as an example, you're probably used to disjunctions again in language arts. So the example I have here is people attending a volleyball game need, oops, I mistyped that. That's not good. So I'll just cross it out. Need an activity pass or $5 to get in. So if you go to the volleyball game, you can either have an activity pass or $5 and you can get in. If you happen to have both, that's fine. It doesn't hurt anything, but you just need one or the other. Whereas if it had been a conjunction, you would have needed both. You would have had to have the activity pass and the $5 to get in. So the way we start most of the problems isn't going to be any different. What happens is at the end, whereas with conjunctions, you're looking at where the two graphs or the two inequalities would overlap or have in common. With this one, as long as either one of them has it as part of their graph or part of the inequality, that's going to be part of the final solution. So we'll take a look at those. And what we're going to actually do is we're going to compare doing three problems, and we're going to show what it would be with a conjunction and what it would be with a disjunction, so we can see what's similar to the problems and what is different about the problem. So rather than showing things that are exactly like what you're doing, we just kind of go over kind of the basic concepts of what happens. So I'm going to start by making some number lines. So I've got three problems here. So these are actually ones taken from your last assignment, and this is going to be my number line right here. So I've got number lines for all of these. All right, so I paused just so I could fill in the number lines a little bit faster without you having to watch me type all of that. But what we're looking at is just look at that left column. So what I have is I'm going to be looking at two inequalities. So I have x is greater than 4 and x is greater than or equal 2. So what I want to do is I'm just going to graph that as I see it, first of all. So I'll use, so let's see, x is greater than 4. So greater than, I'll use an open circle and my arrow is going to the right. For the other, it says x is greater than or equal to 2. So I'm going to use a solid point there. And then this one also is going to the right. Now I'm just going to go through, and all I'm doing is I'm just going to graph all of these individual ones. So this one says x is less than or equal to 1. So that's going to be a solid point going to the left. And the other one, which I'll show in purple, is x is greater than a -3. So open circle pointing to the right. Next one, x is less than a -1. -1, open circle pointing to the left. Or x is greater than or equal to 4. So solid point could be equal, pointing to the right. So what I've done at this point is just graphed the different inequalities. Now notice I don't have an disjunction or conjunction symbol between these two, and I did it on purpose because we're actually going to end up showing both. So to go through this, if I want to show the conjunction of the two, remember I'm looking at what do they both have in common. What they both have in common is starting at 4. So going to the right of 4, they both have that in common. Now, notice that the purple one doesn't actually include 4. So when I do a conjunction, I can't include 4 if they don't both have it. So I'm actually going to graph this one as an open circle pointing to the right. This is the conjunction of those two. It's what they both have in common. What they both have in common is numbers greater than 4. So if I were to write that now as an inequality statement, I would say, well, combined, what they both have in common is they have values that are greater than 4. It's what they both have. Now for the other one, for a disjunction, as long as either one of them has it, I'm going to include it. So I'm going to look back up to the top. So this one has all values greater than 4. This one has all values that are equal to or greater than 2. Well, as long as either one of them has it, I'm going to include it. So this one starts at 2, which is of the 2 is the one that goes further to the left. And then they both go to the right. So the disjunction, as long as either of them has it, that's what I put down. So in this case, combined, they are x is greater than or equal to 2. So if you notice this, if they're both pointing the same way, one of the equations, or one of the inequalities rather, ends up being the conjunction, and the other inequality ends up being the disjunction. And that happens to be true if both of the arrows are pointing the same way. It's just a matter of which one kind of started further back or which one started further ahead. Looking at the next one, we've already got the inequalities graph separately, so we're looking for the conjunction. So if I'm doing the conjunction where I'm combining, what do they have in common? Where do they overlap? Well, in this case, they overlap between these little spots. So what they have, and so going from not including -3, but starting just to the right of -3 all the way to 1. So in this case, I just keep the same endpoints I had before, but I'm just showing what's in between. Where do they overlap? What do they have in common? That is the conjunction. So, and if you have just a line between 2 points, in this case, x represents that stuff in the middle all the way to the end. So I'm actually going to write x in the middle, and it is greater than the -3 and less than the 1. So you'll get an x in the middle if you actually have a line just going from one endpoint to another endpoint. And then you label or name the endpoints as -3 and +1. So where it starts and where it ends end up being the things on either side of x. So now we're going to do the disjunction. So as long as either of them has it. So this purple graph has everything to the right of -3. The red graph includes 1 and everything to the left of 1. So if I actually, both of these arrows are going to go on infinitely. So in this case, they actually cover the entire number line. Not alone they don't, but combined, or either one of them. If so remember, it could be either purple or red to cover any number you could possibly think of. So the graph for this would actually be something just like this. It just covers the entire thing. So there's actually every single number you could think of. So the answer for this would be all reals is actually the answer. All, because anything you could come up with is either going to be on the red line or the purple line. So all reals. Sorry, I probably should type that instead. It'll look a little nicer. So that is the answer. So all real numbers will work. And last one. Get back to my drawing tool. All right, so for the conjunction, remember what we have in common in this case. Where do you look at that farthest column right? Purple and red do not overlap at all. We have nothing in common. So this is what we call an empty set because there's nothing. So either type empty set or that little symbol that's slash. So they have nothing in common. I can't really graph it because there is nothing they have in common. As an answer to the empty set. And then for the conjunction between these two. So this time I basically copy what already is there because I can't combine them because they don't overlap. But remember, it's just one or the other, whether it's red or purple, either one. So in this case, that's what the graph would look like. Notice I'm just basically copying what's already there. And then as a written inequality statement, I'm actually going to have to use like or. So x is less than -1, or x is greater than or equal to 4. I'll add or equal to thing in just a moment here. I'll put that on. So that is what we have there. So keeping this page up to kind of see what's interesting, hopefully realize what how this learn how